Hi! We're rapidly approaching Vintage Computer Festival 2026 and I want to have cool exhibits this year. One of those exhibits will be my relay computer. And if you remember from last video, that has not been yet finished. This is the first box that we're working on today. So down here, I built this in a live stream because it was rather complicated. Down here we have our sequencing unit. I actually don't fully know how it works anymore. We need to hook it up and look how it works. But basically, the concept is we have an oscillator here that just does basically oscillate between the two relays. And then a sequencer which should set those relays in sequence somehow. I think the lower ones are the ones that actually sequence and the upper ones are... Anyway. So, what we need to do, we need to hook up this clock to our first instruction fetching register, which is up here. So it should, on the last, it should already reset that register. And now we need to hook up that it takes the program counter, outputs that onto the memory address bus, takes what the memory gives back and loads it into here. That should be easy enough. So it's now completely wired up. Alright, as you can see, right here, there's a lot of wires in here. It's a rat's nest. Also don't mind that relay, it's a spare. But let's hook up some power to it and look what happens. Okay, so as you can see, not much is happening except that light bulb come on. So what we need to actually do is we need to connect another signal. I believe it's like one of those. Huh? Oh, okay, I found it. Okay, as you can see, nothing is happening. That's because I need to connect power to, I think, this pin. Yeah, this pin here. And now we can see the clock here is running and the sequencer is advancing. We can even see that... Okay, no, the sequencer is not advancing. Okay, we can even see... Why is it? Okay, it's oddly unstable. But it resets the thing. It doesn't used to be that unstable, but I don't know why. But yeah, so this module is now working. I want to take a little break from the box wiring. As you can see behind me, there is a little rack that I built that houses all the 5 boxes. Maybe soon to be 6, but I only have like housings for 5. But as we all know, it's only a real computer once it has a blinking light front panel. And for that, I have this piece of scrap wood. So this, I will try to mount somewhere around here to have a blinking light front panel. It is now on me to somehow come up with a creative design of this wooden plank for a design. Okay, so I have now actually made quite a lot of progress. So first, I installed the whole front panel or operator panel, and I admit it didn't come out that pretty with the clean things. I need to clean it up somehow a bit, but at least like the whole like concept works for now. Then I think we have our first actually final. No, I don't think it's gonna be final. There are spare relays, but this box is completely wired up to be hooked up. Now it's gonna be my task to take all the wires that come out of here, I think on this side, and hook them up to the rest of the machine and the front panel and everything. And then complete all the other boxes one by one, but that will be nice. But this is the most important unit for us for now because it provides the clock. So once I hook more things up to this, the automatic operation where it clicks and clacks will be working. So let's do that. Okay, so I now have wired up some things. We have a little bit of wires here that go to the panel. The panel is not yet, whoa, wait, let me show you. The panel is not yet wired up. There's just some alligator clips and stuff that do the grounding. And there is my new power wire. So this is my new power wire going to the power supply. So now I will try to turn it on. Okay, so we are looking at it. Are you ready? 3, 2, 1. Oh, we're getting things. Okay. Something ain't working right yet. Okay, maybe that. Oh yeah, now it looks good. But now nothing happens anymore. The clock is also stuck on for some reason. Why is the clock stuck on? So some things are not working. So the clock is stuck on for some reason. If I clock the clock manually, it works. Well, let's debug that. I may have fixed it. So let's turn it on again. Okay. So now I should be able to step it. Does it now work? Yes! Haha, look at that! Look at that! Look at that! That's amazing. Okay. So I can now step through with the step switch. And I can run it. Yeah, that's amazing! Oh my god, I love this so much! This is so cool! This is the first part of the computer working! Is that cool? Oh my god, I love this so much! Oh my god, I love this so much. And I can stop it, and then I can... Oh, I can clock through it. I can clock through it without having the clock gone. That's a problem. that shouldn't be like that. That's not good. But this is so cool. I love this so much. I am so happy. I am genuinely so happy. This is amazing. Let me put on the cover. This is genuinely the best thing ever. This is so cool. I'm happy. I've worked so long. This was so much effort. Oh, it crashed. it's so little of the computer working, but like this makes me unbelievably happy. We interrupt your regularly scheduled programming by bringing you this important message. The modern electronics engineer faces many dangers. Incorrect footprints, misaligned drill holes, copper traces drawn with a permanent marker, and most terrifying of all, having to build the same circuit twice. Fortunately, science has developed a solution. PCBWay can manufacture your printed circuit boards directly from your design files, complete with proper holes, neat copper traces, and considerably less swearing. Simply prepare your Gerber files, select the required specifications, and allow the enormous industrial machines to do what your tiny workshop drill press cannot do. PCBWay also offers services including PCB assembling, 3D printing, CNC machining for projects that have escaped the sensible boundaries of an ordinary circuit board. This program is sponsored by PCBWay, whose support helps keep this laboratory supplied with components, materials, and questionable engineering decisions. Visit PCBWay using the links in the description to get $10 off of your first purchase. Now we return to your regularly scheduled program. So, now my next part is to take this it's heavy. Take this logic unit. This is the logic unit, a couple of spare relays, and then the second part of the instruction register. So we need to put in all the instruction register things. And I just remembered that we need to have a clear line as well. So we need to probably take out the other thing and add a memory clear, like until I have set, but I'm pretty sure I haven't because I wasn't that smart. Okay, it's now very late, but so I had to do a little modification on this one to also output a reset signal for the second half of the register, which is up here, right? So now I also finished the whole second box here, and now I'm gonna have to remove this and hook this box up to this box, and also hook up some more of the thing, of the front panel, and then we should be able to fetch full instructions and technically even do some logic. So that'd be cool. Hold on while I do that. I feel like I have done enough for today. But we're gonna test whatever we have right now. I'm gonna turn it on. Okay, there's nothing happening, which I am not surprised, because there's not much to have to happen. Wait, it should at least reset. Oh my god, I hooked up everything on the wrong... Oh my god, I'm such an idiot. Ah, I need to mirror it. I need to mirror all of it. Okay, I'll do that now. And I'll hook this up, and we're gonna turn it on, and things happen. So let's whoa! Look at that! It loads first the first half and then the second half. Bump, bump. This is perfect. This is amazing. So, what just happened here? I think this needs some further explanation because I did a very bad job in explaining it actually in person while I tested it. So basically, I have made down there, there's a box that currently emulates memory with an Arduino. There's some relays in there that translate the voltage levels, and that's basically it. And I can access this by accessing memory. So those 5 switches have 3 positions. Basically in the middle, the machine has control over which address goes to the memory bus. If I put them down, they are forced to 0, and if I put them all up, they're forced to 1. There's a little problem with I mixed up little endian and big endian. I'm gonna change that in the future, but not now. But what I can do now is I can go to address 0, for example, and I have 4 data switches where I can put in a pattern. I can deposit that, the read-write lamp goes on, and now when I examine it, I can see the 2 LEDs go on. Now we turn that off, we go to address 1, we're gonna turn both the other thing on. I accidentally go to the whatever. So I turn the other address on, I turn that on, and I deposit that. And now when I read it, I have the other pattern. Now, when we put the thing back, so what happened here is I ran the computer. Don't mind that lamps. This is just that. Well, yes, there goes my lamp fuse. Now what happens is when I step to step 1, here, step 1, I can ignore that second lamp. Step 1 means the first half of the instruction register fetches the address that the value that we have on our address. Right now I have manually set the address. And now let's go to the second address. Oh, whoops. I have now put F1. And now when I step forward to the second phase, I can see that pattern go latch into the second register. So I can now load an entire instruction from memory or fake memory easily. So there's that. That's how this worked. That's it? That's it? Does it load the pattern? Okay, it is very goofy when it comes to that. Why does this turn on? This isn't supposed to turn on, and this isn't supposed to turn on either. So it doesn't load. It loads something, but then it finds some path. I think I need to add some diodes. But yeah, this is very satisfying. This is working. This is very cool. So now we're doing another test, and now I'm trying to... So here we go, run. Yes, look at that. It's not weirding out anymore. It's loading the correct value. And now I wanna have this. Wait, this is. So we're gonna deposit this. Okay, so then we're going to run. Perfect! Haha, this is so cool. I love this. Perfect! this works. This works. This is amazing. So, after that last clip that you just saw, I stopped recording for the night. I stayed awake till like 8 a.m. in the morning or something, or 7 at least, and just continued wiring on it. I hooked up the program counter to the readout, but also to all the other things. And now when I turn it on, I have a program counter where I can step through, and it increments, right? And it will also output the content of the program counter into the memory bus, as it is supposed to do. So I have now fully automated the process. I don't fully know why I didn't record it. It was probably too late in the evening. But this is unfortunately also the most I can do for this video. I really wished I could get it to actually execute some instructions, but I did not manage to do that. So we have to move that to the next video. But I am quite happy that I can finally move on to something else, because I am quite burned out. I'm working on this thing for like now 3 weeks non-stop. So thank you so much for watching. If you enjoyed that video, please hit like. If you support this kind of content, please leave me something on Patreon. It really helps all a lot. You can also buy my music on Bandcamp, and other than that, thank you so much for watching. Have a wonderful time. Bye!